Hey guys, welcome to Endless Studios, casting to you at 4 o'clock on Tuesday. I think it's Tuesday.
All day.
That's right, yeah. So, of course, I'm Natalie and I'm here with Brian. Hey, Brian.
Howdy.
Good to see you
I don't know
again.
why I said I'm not in Texas. I'm still in New Jersey. I don't know why I said howdy, but
I love it. I know. And one of my favorite aspects of talking to you on this cast is I love your New Jersey accent.
I'm told I have a New Jersey accent. I don't hear it.
Oh my
Um,
gosh, it's the best. It's like it's wonderful vocal stylings from you. I could listen to it
I'll
all
tell
day.
you. I'll tell you who in my household has the New Jersey accent is for reasons we don't quite understand because I certainly have one. I'm being facetious. I know I have one. My wife has a mild one. It's not as strong as mine. And some other members of my side of the family, in our extended family have them. But the person in my house who really has one is my daughter, my 4-year-old daughter, who has a ridiculous New Jersey accent. Whether this is she's playing the long game to audition to be on you know, the 2040 season of The Real Housewives, I don't know. But she's really got it, and we're not entirely sure why.
That's amazing. I just love the image of this little kid like talking in this intense Jersey accent. Man, she's like, all right, yeah, you're the boss, right?
Yes. And the strongest evidence of that is if you ask her where she's from, she will tell you New Jersey.
Oh my God, that's so cute. Oh my gosh.
We're very proud.
I'm proud too. So I wanted to welcome folks in, regardless of what your accent is. You're welcome here on our live cast about game making and coding. Particular warm welcome to the folks who are in our pilot program. I know you're probably out there diligently watching. Say hello in the chat if you're joining. As usual, we'll say hello to you. And just generally kicking the cast off today to ask folks who are in our pilot program if you guys happen to have any questions or things that we can address about your experience of learning game making in our classroom on Moodle. We want to help you guys if there's any roadblocks in your process of learning or working on projects. So when we're here on the cast, even if we're talking about Unity, it's a good time to ask us within the hour. We will always respond to what you have to ask or what you have to say. I see Ms. Rogers saying hello. Hey, good to see you. um, but yeah, again, one of the realities of Twitch casting is there's a little bit of a lag. So if you type a question, we might not respond to it immediately. But we always see everything you guys type, and we want to answer your questions and help you guys along. I see Ronan is here also. Ronan28 is what I'm trying to say. Hey there.
Hey, Ronan.
Awesome. So glad you guys are with us every cast. It's so great to have you and everybody else out there. So, Brian, today we're gonna continue talking about the shooting gallery game, right?
That's the plan. I think yesterday we officially were beginning work in the production phase of our shooting gallery mod project. And we started with a tour of Unity, which took up pretty much all of the live cast last time, so that folks were oriented to what they were going to see and some of the terminology we were going to use when we were talking about stuff in Unity. If you didn't happen to catch yesterday's live stream, I would strongly recommend that you watch it in the archives, which you can get to from the main course page. You can find it on our YouTube channel. That would have been the live cast from the 20th of July. I would, again, strongly recommend you take a look at that because it will introduce you to a lot of the terminology we're going to be using in today and future live casts when we're working in Unity, much of which also applies to the Endless Mission, where I know some of you are now starting your coursework. You're up to that point in the course.
Yeah.
Today and going forward, I'm going to assume you have watched that live cast, and therefore I'm going to just throw terminology around that was already covered. I may take 2 sentences to review what something is, but I won't go into it in detail. And so if something does seem a little bit unfamiliar to you, it was probably covered, or at least I think I remember us having covered it in a prior day. And again, that live cast from July 20th is probably the one to check out if you want to come up to speed on some of the terminology you may not have heard before.
Absolutely. And this is just the time now where when you're watching this live cast, um, we're going to be dense with information. So if you hear us talking about something and you're like, oh, what was that? The nice thing is you can always go back and skip to that point in the cast later on. And at that time, watching the recording, you can open the Endless Mission, look to see what we're saying, and confirm that you understand what we meant. So, Brian, I think we talked, just to summarize, projects and assets. We talked about the hierarchy. We talked about some of the details of moving around and just sort of existing in the Unity scene. And then we talked about the inspector. Is that a good summary of what we talked about in that July 20 cast?
I think you covered it, and we at the because we ended up being a little time compressed at the end. We very quickly did an overview of the relationship between what you see in the inspector and code, which is where we're going to spend most of our time today. So I think that was a good stopping point, and it'll be a good review today. Now, because we're going to get into code today, and I know for some of you participating in the course, this will be the first time you've interacted with any code before, or certainly code in Unity and C Sharp. It's going to serve as a little bit of an introduction. And I want to take a few minutes at the outset before we actually get into the code and sort of talk about how to approach learning, viewing, and interacting with code for the first time, if it's the very first time you've seen real textual code, or the first time you're seeing code in a new programming language, if perhaps you've used another programming language before, either a textual programming language like C Sharp, which we'll be working in today, or Java, or Python, or perhaps you've done some coding in a visual programming language like Scratch, but how to sort of approach learning code for the first time. Now, within the course itself, Natalie, in the classroom, we've got a whole series of videos that shows up, I think, starting in Unit 5. And then there are recurring videos throughout the course progression where we go into more detail about some of the understanding code and C Sharp and how to sort of read and interpret a C Sharp script. So I'm not going to go fully into detail on everything here, but many of the same principles that are introduced in that video in terms of how we think it's productive to learn and look at code, I think they apply here. And so I'll talk briefly here at the start just to kind of set the stage for that. And then we'll get right in and we'll see it in action. Does that sound good, Natalie?
That sounds great.
Okay, so let me go full screen here for a second and hop on my learning code and encountering code for the first time soapbox, and I'll try not to stay up here too long, and then I'll jump right off. So you guys are going to see code in C Sharp, again, some of you for the first time. When you take a look at this, a lot of it, therefore, will be unfamiliar to you. And a lot of it, because it's code, especially if you've never worked with textual code before, is going to look really weird and bizarre, and you might as well be looking at hieroglyphics. That's how looking at new code is for everybody. And it can be a little intimidating and a little different if that's not how your brain is used to working. But, Natalie and I are here to tell you that's going to be okay. We're going to get through it together, and approaching it with the right attitude or the right foundations is, I think, really important. So as we look at code today, I don't want you to try to focus on understanding what every single line of code is doing or every structure in the code is doing. I certainly don't want you to try to remember or feel like you have to memorize what code is doing, what it's making, what this piece of code is making work, what this specific function in the code does. I don't want you to worry about memorizing that stuff. One, because if you're trying to memorize it, you're probably not focused on the stuff it would be more important for you to take away in this early stage. And number two, you don't have to, because anything in any programming language that is a specific instruction or command or a function that you need to know, ultimately it's something you can look up with a search on the internet and get back to or understand how to use it or do it in more depth. It's more important to understand the overall structure of the code, how things are flowing, and how we're using different techniques to solve the real in-game challenges that we're trying to overcome, and how we're using those techniques to implement the real in-game behaviors and things we want to do that are part of our mods design at a high level. Not every detail. You don't have to be down in the weeds. You don't have to memorize it. And that'll be the spirit we're presenting it in, and what we emphasize as we go through. So that's sort of my quick diatribe on that, Natalie. I don't know if there's anything you want to add or you found helpful with introducing folks to code for the first time when you've taught.
Yeah, I do have something that I could add here, and I don't have as long of a soapbox. I think
Not a
you're
lot, not many people do.
well, you're special in that you have a soapbox about a lot of things related to coding, and you're one of the people that I've felt is the most clear about how to learn it. So I always learn more about coding from you when you talk about it, honestly. So to the viewers out there, I would say listen to Brian. He always tells you, he doesn't tell you any extraneous information.
Oh,
Um,
that's certainly not true. I'm full of extraneous information. That's
oh
that's
my
not,
gosh.
we got to be honest here now. Well, no, but
Well,
thank you, Natalie. I appreciate that.
yeah. Um, the final thing I would add, just to give one more perspective, is there's kind of two different tactics for learning code. One of them is to start with a thing that you want to do, which is what we're doing on this live cast. So today, I believe, Brian, we're going to look at some implementations for the first item on our plan for the VR shooting gallery, which is to implement crits and multipliers. So in that style of learning how to code, we start with this idea of something that we want to accomplish in the code. And then we open scripts, we dig around in there, and we see if we can get the code to do what we want it to do. And then we test that in a game. The other approach is reflected in the videos you mentioned in the Moodle course, which starts at the beginning and gives you a ground up tour of C Sharp and C Sharp scripts in a game project. And rather than starting with an implementation, that approach starts with saying, what is the structure of a script? What are those using directives at the top? What is a class? What is all this stuff? And that goes through all of that important information in a very reasoned and logical way. Honestly, I think using both of those styles is important to really get a picture of how to be a good programmer. You need to learn the overriding structure, and you need to learn how to implement what you want to do. That said, some people may lean towards one or the other, and I would just start with the one that feels the most logical to you, and then also use the other one, or at least sample the other style when you can and where you can. And think of it as a process that is going to take a while, right, Brian?
Yeah, I think that's absolutely true. You never stop learning this stuff, even if you are a working professional coder. And I should point out, that neither Natalie or I is our day job being engineers or programmers on a game. I mean, I think in both of our careers, Natalie, correct me if I'm wrong in your case, there, not being necessarily in game making, but there have been other times where our day job was being a developer of some kind, right?
Yep, sure.
And but neither of us is a game programmer, and a lot of the structure of what you're going to see today, or in other learning projects that you do in Make Room, the code that you'll see and the techniques that we're using aren't necessarily the same techniques we would use or a professional developer would use if they were trying to do the same thing in a professional game. When a professional developer is making stuff and writing code, they're super focused on optimizing for things like efficiency and how well does the code run, and is it going to, how many, if I do this way, how many frames per second of performance is that going to cost me? We're not as concerned about that stuff here. We're more concerned about using techniques that will actually help make things clearer and concepts clearer for you as learners to understand. And so, if you are a professional developer and you're looking at this, you will probably see some stuff and go, that's not how I would do that. And you're absolutely right. There's going to be a bunch of stuff like that. Again, not that any of these techniques are unsound. They'll all work. They just might not be the most performant, efficient, or, you know, rigorous canonical ways you would do stuff in a professional game. But the one thing I do also want to point out to maybe close this thread, Natalie, in both of the approaches you described, whether you're starting with, hey, I'm trying to do something like implement our mod for this game, or it's I'm trying to understand something more from the ground up, both of those techniques, the way we do them here in Endless Studios, start with code that already exists and is already working, right? And that's another thing as you learn code, we found to be extremely valuable, right? Notice that we're not starting you here with a blank page anywhere. We're not saying, hey, here's like a thing we want you to do, an empty space we want you to fill in with code. We're actually saying here, like today, no, we're starting with an existing game that works, an existing code that makes it work. We're going to mod it. You're going to see how it works, and we're going to mod it to do the things we want to do. And we think for a lot of reasons, that's a better approach, not the least of which is you get to see stuff in an already working system, and you get to see the relationship between the gameplay you see on screen when we play the game, or as we've done several times on the live cast, and the code that makes it work.
Yep. I think that's a great way to learn. And of course, we're focused on helping people learn, right, Brian? Not, optimizing for FPS, because the people that do that optimization at some point went through a learning process. And when they were learning, they were hacking stuff together too, just like we do.
For sure. And so the last thing I'll say about that before we dive in is if you, as we go through, you have questions, whether something we say is unclear or whether you just want to know more about something, please add them to the chat, and we're happy to take up, diversions and happy to answer questions. We don't sort of strictly have to stay on the plan we would otherwise be on. It's a learning opportunity. It's supposed to be interactive. So please interact with us, and we're happy to answer any questions that you have. So Natalie mentioned it a second ago, but just to review our implementation plan. Today we're going to start with the implementation of crits and multipliers in our game. So what are crits and multipliers, just to review really briefly? A crit is the idea that sometimes when a weapon has its effect, and in this case the shots from the blaster, normally they deal a certain amount of damage. And in the game's health system, they deal 5 units of damage right now. And the notion of a crit is that sometimes, some percentage of the time, instead of dealing their normal base damage of 5 damage, they will get a bonus on their damage, right? And the terms you hear to describe those things are the percentage of times that crits happen, are the critical hit rate or the crit rate, are terms you might hear for that. And then the additional bonus damage is the crit damage, or the crit D sometimes are terms you hear for that. So we want to make it so that our blaster weapon that our avatar fires has the ability to crit, right? Has the ability to support having critical hits some percentage of the time and dealing some bonus damage when that occurs, right? That's a critical, that's crits. A multiplier, the idea there is certain events in the game when they happen contribute to your score, right? And right now, Natalie, there's only one event in our game that contributes to your score, and that is
killing an enemy.
Killing an enemy is the one event, right? So right now you get 50 points for killing an enemy. And again, the support we want is some of the time being able to say, while this multiplier is in effect, instead of getting just the base 50 points, you get a multiple of 50 points. It could be 2 times or 1.5 times or 5 times the point value while that multiplier is in effect. So what we're doing today is we're adding the basic support under the hood to have crits and multipliers work in our game. Now, as Natalie pointed out before we got on the cast today, every day before we get on these casts, we spend some time, planning what we're going to talk about. Natalie, you asked a really good question about what we were going to be doing in the implementation today. Would you mind repeating that question for everybody?
Yeah, so when we were talking about multipliers, I was curious like what was going to be the, I asked Brian like, how are we going to set it up to trigger a multiplier being in effect? So I was wondering like, again, we have this idea of an event in a game. I think you talked about that a little bit on the cast, Brian. Um, and I was like, what event causes you to have a multiplier? Like, do you have it all the time, or is it you collected something? And I wasn't actually clear on that from this implementation plan, so that was what I asked.
Right. And I think what that question points out is that there are sort of two parts to the implementation of crits and multipliers. One is let's make it just so that we can have critical damage, and multipliers in our game, right? Just so that and that's what I mean when I say the base support for that in the game. And then there's the notion of how are you going to trigger it so that those things are in effect. And that second part we're not going to do today. And my answer to Natalie when she raised that question was triggering that stuff is going to be making that stuff actually trigger is going to, when we wanted to, will be part of our work with the wave system. It won't, because we're going to relate that stuff ultimately to the waves. But before we can do that, we got to get the base support in. That's what we're going to do today, right?
Yep.
So with that said, that's our plan for today. So my hope today is to knock off everything I've just highlighting here, which I think is very accomplishable, even with taking a little longer because you guys are going to be seeing some code for the first time. So let's head into our game in Unity. We took a look at this yesterday, and we took a look at the different objects in our game world. We spent time, if you remember, zooming around the game world here in our scene view and looking at stuff. So before we get into making any changes here and implementing our a crit system or our multipliers, and we'll start with crits just because they're first in the list. A natural question is, well, how does damage work in the game right now, right? And it's worth reviewing that because it'll be the basis of our crit implementation. So, like a lot of things in games and game programming, the way that damage works in this game is distributed into a number of places in the game. It's distributed over a number of objects in the game world and in a number of blocks of code that make everything work behind the scenes, right? And if you just think about that for a second, it makes sense because if you just consider the concept of damage in a game, damage is an event that happens when things interact, right? Damage is the result of an interaction between something that causes damage and something that takes damage in response to that cause. And so if we just analyze this game for a second, and Natalie, I'll cast you in the role of a game designer or a student of game design here, because it's easier for me to ask it as questions rather than to just talk about it. What if you just examine the gameplay of this game? What are the things that are interacting in this particular game when damage happens?
Let's see. So, what comes to mind is that there's two types of damage. There's damaging the drone and damaging the player.
Excellent. So, true and an excellent point, right? So, in this game, we know the player can take damage inflicted ultimately by the drones, and the drones can take damage ultimately affected by the player. Now, my next question is, for the perspective of crits, do we care about both kinds of damage, or is only one or the other relevant to us?
Well, in the situation of crits, I think we were talking about the damage that the player is doing. Um, Theoretically, we could do an implementation of both, but my understanding was that we were interested in having the bullets that the player shoots occasionally be able to deal critical
Yeah,
damage.
I think that's right, which means we only, from the perspective of the thing that takes damage, we only care about the drones taking damage.
Yep.
right? So that's the what's going to take damage side. So the drone is the thing that's going to take damage. What about the what causes damage side?
Right. And I think I just said the bullets. And so a little bit of insider baseball because Brian shared this project with me between the casts. And I do know from taking a quick look at it that the bullet it is a game object that's spawned when you click on the trigger. Um, so my assumption is it's that bullet.
You assume correctly. And that may seem a little counterintuitive or indirect, right? Because when we speak about it informally, we say, well, the player damages the drones, but it's not. This is not like a street fighting game where the player like is punching the drones directly with his fists. Um, the damage actually happens because the laser bolt is the thing that's causing it, even though the player causes the laser bolt to fire by pulling the trigger, right? And
Yeah.
that's super important here because it's the two places we got to look to understand how the system works. We've just identified them. One is at the drone, and the other is at the laser bolt, right? And so your first reaction when I say look is like let's literally go find those things in the game world and look at them. But there's a problem right off the bat, and Natalie alluded to it, which is if we start looking right now, we won't find either enemies or laser bolts in this game world, no matter how expansively we look at it or how close we get to things. We won't find those things. The closest thing we'll find in this game world is the player, which, as we talked about yesterday, is right here where these icons are in the middle of my screen. Even though we can't see him because the player in a VR game itself is invisible other than the shield and the blaster models. But we don't see any laser bolts and we don't see any enemies. And that's because, as Natalie mentioned, both of those things are things that spawn into the game world later during gameplay. They're not there at the beginning. The enemies spawn in through those portals, and there's a whole system that knows how to do that, and spawn them, how frequently they spawn, when they start spawning, the precise location of the spawn points because as they move around a little bit. That's going to be very relevant to our discussion of the wave system probably tomorrow, but it doesn't matter now. But there are no enemies at the beginning of the game; they all spawn in. And likewise, as Natalie said, the laser blasts aren't there at the beginning of the game either. They are game objects, as the enemies are, but they spawn in during gameplay. In the case of laser blasts, when you pull the trigger, you spawn one. Now, a way we can see this is if I play the game now, what I'm going to do is I'm going to bring my game window up here as well so it's reasonably large. So we won't see the scene for a second. But I'm going to play the game, and what I want you to do is watch over here in the hierarchy as the game starts to unfold. So I've started to play, and all of a sudden we see an energy point, and we saw an enemy come in, and we saw a laser blast object come into existence. And if I wait here, you're going to start to see more things where I shoot getting added to the hierarchy. Those represent the enemies and the laser blasts spawning into the game as I play, right? You will also observe that sometimes things go out of existence. So when I destroy enemies, the enemy I destroy goes out of existence. When a laser bolt hits an enemy, if you were to slow this down and look at it really precisely, you would see that laser bolt disappear. And you can see even right now, there are still a bunch of laser bolts, these laser bolt clone things hanging out in the world. And I can tell you that's because those are laser blasts that didn't hit anything and are flying off into space. And eventually they will go away because I've done some neat coding practice that if the laser blast continues to shoot up into space and doesn't collide with anything after a certain amount of time, the game automatically destroys it because it doesn't need it and it'll save on resources. But that's what's going on. And now when I stop the game, as I just did, and it goes back to its normal state when the level starts, now we don't see any more of those objects that spawned in, right? So those things don't exist in the game world. How can we interact with those things is our next question. So there's a couple of ways we could go about this. I'm going to cheat in the interest of time, right? Because I know that the code that makes this stuff work lives in two places. It lives in two scripts, right? And we talked about scripts at the very end of the live cast yesterday. A script is a custom piece of code that you write that enables a component over here on an object in the inspector, right? Again, I threw out a lot of terminology there that's covered in yesterday's cast. But one way we can see that is what I've just done, and I won't go into the details of how it works, is I just brought up that represents the laser bolt and that is spawned into the game when a laser blast is fired, right? Again, that's not something that exists in this scene right now. It's in a special place in our Unity project where I can, called Prefabs. If you remember, we looked at folders yesterday and we saw this Prefabs folder over here in the project window. Prefabs are a technique in Unity for creating something you're going and saving something you're going to use over and over again. So here I've created a prefab of my laser bolt, and every time my laser bolt gets brought into the game, it's effectively a copy or a clone, like you saw, of this prefab laser bolt getting added into the game world when I shoot. And if we look at this laser bolt I've selected, it has a bunch of properties on it. It does have a transform. You know, right now it isn't anywhere in the world, so that's all set to 0, 0, 0. It has some other components on it that have to do with its visual appearance and its ability to collide with things, which is going to be very important later. It actually has some physics properties. That's what this rigid body is doing things. So it technically has a little bit of mass, which helps me move it through the world when I shoot. And then at the very bottom here, it has something called laser bolt behavior. And in parentheses, it says script. And we know from yesterday, that's a custom, unlike these other things I just went through, which are components I can freely use. They come with Unity. I can use them whenever they want. This script is something we wrote the code for to enable the damage-related behavior of the laser bolt, right? And behind the scenes, if I look at the code for this script, and I'll pull up my code editor window here, right, you can see I have a script open here called laserboltbehavior.cs. That's the file name of this C# script that's stored in my Unity project. And that laser bolt behavior corresponds to the laser bolt behavior you see here as the name of this component. So again, that script is the script that makes this component work. One thing we can see when we look at this component in the inspector is we see where it says units of damage, and there's a value of 5 here. Just like when we were playing around with the transform, where we knew these values represented the location in the XYZ coordinate system of an object. This value represents how many units of damage we want this laser bolt to deal when it collides with something that it damages, right? And it's, as I mentioned before, that value in the design of our game is set to 5. I could make this anything I want to, right? I could say it's 10 or 1 or whatever I want to make it. We'll leave it at 5 for now because we know that's the correct value that balances our game, right? Anything that is visible to you on a component in the inspector here that you can edit like that is called a property. That's another kind of big buzzword you're going to want to know. These are properties. And again, this is really works kind of on an analogy to things in the real world, right? Or if you've ever played a game where you customize your avatar, right? If you think about the face of your avatar that you customize, I say because I'm staring Natalie at our faces in my view of the live stream, right? You think about the settings you might adjust on your character's face, right? His nose length, or which, cycling through the different hairstyles your character can have, or the eye color. Each of those things is a property. And then any specific choice you would make, like nose length 5, or I want, hairstyle mohawk, or I want green eyes. Those are particular property values you can select for those properties. And the same concepts apply here. And as a game designer, if I were messing around with this game and tuning this game and trying to decide, well, what is the right setting I want for units of damage? What's the one that makes my game work the best? I can go ahead and change this to whatever I want it to. Click that good old play button up here in Unity and try that new setting. In fact, I can even change this while my game is playing. I can hit the pause button and modify it, and then that change will take effect for testing purposes in my game while I'm playing it. And I can do all of that testing as a game designer in Unity without having to actually write or manipulate any code. And Natalie, I think that's one of the things that's really powerful about a tool like Unity and this approach to game making.
Yeah, I would agree with that. I mean, it's kind of overwhelming at times because it's like, oh, I can really like make this do anything. And that's when you get into needing to do some of the design work we did where you say, oh, I can literally add anything to this. But what am I going to add to it? And you narrow it way down to, I just want to add crits today.
Yep.
And
exactly.
I think that's a helpful way of learning too, because sitting down saying, oh, I have to learn it all because it can do anything is just a recipe for being so overwhelmed by the infinitude of what Unity and game making platforms like the Endless Mission can do.
I love that word infinitude that you just used. That's like a very, very accurate and poetic word. I like it.
Well, I am a poet.
There you
so.
go. And you know it. So, as Natalie says, we know we want to add crits, right? And we mentioned that there were two pieces of information we needed to know in order to make crits work in our game. The crit rate and the critical damage value, right? The bonus on your damage you get when you crit, right? And those two things we want to now represent as properties here on this component. Right now, the only property this component has is this units of damage, which is effectively the base damage value of a laser blast when it doesn't crit, right? Now we want to be able to say, how often should I crit? And when I do in fact crit, how much of a bonus do I get on my damage? But we need a way to capture those property values. And now is when we're going to get into code. Because the way we're going to do it is we're going to modify this laser bolt behavior script to be able to capture that information for us. And this is pretty cool, I think, the first time you see it, and mind-blowing in Unity. So if I go back to my code editor and we look at this code, one of the first things we see here is a block of code right here that says units, among other things, part of it says units of damage equals 5F, right? And isn't it funny, Natalie, that units of damage, right, and a value having to do with 5 is the very thing we see over here in the inspector for that component.
That is indeed funny.
What an odd coincidence that is. And of course, it's not a coincidence at all. That's exactly how this works. This block of code is telling the inspector to include that value, to have a place for storing that property value that we can both edit in the inspector, like I talked about, and that our code can use here when it needs to do stuff with that. And so we're going to add values here for crit rate and critical damage value. Now, right away, unless you're familiar with C# or perhaps another C family programming language, this is probably gibberish to you. And that's okay. In fact, we don't even need to know exactly what this does. In fact, I don't. I do know what it does, but I can get pretty far even not knowing that or pretending that I don't. Watch what I'm going to do here to add this stuff. All I'm going to do is cut and paste what I have already, and I'm going to modify it, right? And I'm just going to use common sense to figure out what stuff means here. So the first thing I get is something called a tooltip, and then it says units of damage inflicted by the projectile. So that seems like an explanation of what this property is going to be. And so let's stick with that, and I'll just come up with a new explanation. We'll have the first property we were going to add here be the critical hit rate. And we'll say the chance of any given hit being a crit, right? Then we have this line called private float m underscore units of damage equals 5f. And here's where, if you have a little programming knowledge, this probably will make more sense to you. This line of code, if you know programming, is declaring a variable, right? If you don't have any programming experience, we talk about what variables are a little bit later in the course. The short explanation is a variable is a way of storing data. It's like that your program is going to use. So you can think of this variable as like a container that our code is going to make use of. It's going to refer to things by this name f underscore units of damage. And it's a container to hold whatever value, particular value, we want to specify for the number of units of damage, right? You have probably heard the term variable in algebra before. This has some things in common with the concept of a variable in algebra. For now, if that's where you know the word variable from, I want you to forget it. I want you to forget about everything you know about variables in algebra. Just kind of take that knowledge and put it to the side or the back of your brain. Again, it has some stuff in common. It will tend to confuse the issue more. Just think about this as a container that can hold a value, and we refer to it in code. And so up here where I copied the code from, we called the container m underscore units of damage. Units of damage being a nice clear representation of what that actually is, and it's good to name your variables for what they are so your code can be understood and recognized by someone else. Instead of calling it units of damage, I'm going to call it something else. The m underscore, by the way, is just a convention or a habit I follow in my code to remind me about how I'm using this variable. You guys could, it doesn't have to be there. I could name it whatever I want. Don't even worry about the m underscore thing here. I'm just going to stick with it because it's what I know. But instead of calling this m underscore units of damage, I'm going to call it m underscore crit rate, right? Then we have this equal sign and it says 5f, right? What this is doing is it's saying, it's giving a default value for this particular variable. So if our game designer doesn't change this in the inspector, this is the value it will get by default. I am going to set this value, the default value, to 0, right? And a little bit later, it will become apparent why I'm doing that. Now that I've made those modifications, if I save my script and I go back into Unity, and it may take a second to update. I believe it should update automatically.
It always takes a second
Yeah.
for it to compile and get your changes.
Yeah, it's thinking right now, I can tell.
Yeah.
There we go. So now if I look at that same script again, check that out. There's units of damage, and look at this. there's crit rate. And now I've got a field here for crit rate just because I made those changes in my code. And you can see the relationship between the script and what I've got here. I'm going to get a little fancier with this now because I know some stuff and I want to be able to do this. What I want this number to represent is a percentage chance of how likely it is that any given shot is going to be a critical hit, right? So this ultimately is going to be a percentage value, and we're going to express it as a decimal. So like a decimal of 0.25 would be 25%. So my daughter, who I spoke of earlier, has just come into my office. Hi, sweetheart. What's going on?
Daddy,
Yes, I'm on TV right now.
I just went under in the pool all by myself.
You just went under the water all by yourself?
All the way.
That's amazing. That's so cool.
Oh my gosh, yay.
Oh, and you had goggles on too, and mommy was there. Okay, well that's one. I can't believe I missed that. I'm so excited for you. Now, unfortunately, I got to be on TV right now. Okay, so I'll be down in about 15 minutes, and we can talk about it some more. Sound good?
Daddy, Natalie claps for me.
Oh, Natalie, yes, Natalie did clap for you. Isn't that nice?
Daddy,
She's excited. Okay, but now, sweetie, I really do have to go. Okay, so why don't you go back down with mommy, and I'll see you in 15 minutes. Okay? Thank you, sweetheart.
And she disappears behind the magic of our casting setup.
Isn't it amazing? We have Natalie. We can now say we officially have special guests on our live stream.
Oh, I know. Well, I was listening for her Jersey accent.
Yeah, it wasn't too apparent there.
Oh my gosh, what a sweet person she is. I'm so glad she made a cameo on this cast.
She is a sweetheart, and she certainly doesn't get it from me. So we'll see.
Oh no.
All right. So anyway, back to this. So I'm going to do another fancy thing here. So as we said, this is a percentage value, and we're going to express the percentage as a decimal. So like 0.25 would be a 25% chance. 1 would be a 100% chance. So I want to constrain what a designer could put in here to not being any greater than 1, because I don't want you to have a greater than 100% chance of critting. That would make no sense. And so back in my script, I can do a little trick here, and I can add another line up here, and I can go like this. I can say range, and I can specify the range I want to allow, which is going to be between 0 and 1. And now when I save that and go back in, what this is saying is only allow values between 0 and 1. The F, by the way, is a sort of a reinforcement of what kind of number this is. So the values you can put in here are numbers that have decimal points on them. Basically, they're what in computer science are called floating point numbers. So the F just does that, as opposed to an integer, which would only be like a whole number. And if I go back into Unity here and it does a little thinking again, watch what's going to happen now. So now I've still got crit rate. I've still got a box where I can put it in, but now I've got a slider. And if I drag this slider, you'll see the value in the box start to change. And Unity is smart enough that when it sees that I add that range attribute onto my property here, it knows to be like, oh, cool. In the inspector, when I show that, I'll show it with the slider. And that's super fun.
Yep.
And Unity's got lots of little tricks like that. You can see an example right above here on rigid body. When you have something where a property only has a list of values that it can select from, like for collision detection on a rigid body, it can be one of 4 things. It knows to display that using a drop-down list. When something can only be true or false, it knows to display that with a checkbox, right? And there's all sorts of cool stuff you get for free in Unity when you set up your properties nicely. So that was the first property I wanted to add in my script. The second property I want to add back in my code is we know we needed to add one for the crit damage multiplier, right? And again, I'm going to cut and paste and do the same thing again. So here we'll say for our tooltip, Oh, and I'll show you guys where that shows up in a second too. Uh, the bonus damage multiplier when the projectile crits. Now here, I want this number to serve as I say in the tooltip, a multiplier. So the idea is if your base damage is 5, like our base damage is, and you crit, I want it to be worth, and I set my crit value here, multiplier to 2. It's going to say, instead of inflicting 5 units of damage, I want you to inflict 5 times 2 units of damage, or 10 units of damage. Right? That's how I want this math to work. Now notice, by the way, when I thought about that design and I thought about the math and the algorithm we were going to use there, I just expressed that in math. I didn't write any code. I just thought about logically how I wanted to work. And anything you ultimately want your code to do, first you want to be able to express that clearly and logically as a step or an instruction that you could express in ordinary English or math like I just did, Natalie.
Mm-hmm. Yep.
All right, so in this case, let's rename this variable. So instead of m.crit rate, we're going to call it m underscore crit bonus. And this one, I'm going to set the default value to 1. And again, I have my reasons for doing that. And the range on this, now I want it to be probably less constrained than that, because it certainly can't be constrained just to 1, because that would mean you only ever, when you critted, you only ever had a multiplier of 1, and as we all know, 1 times anything is going to be that value, so a crit would be always worth the same as the base damage. That doesn't make any sense logically. But we probably want to limit it somewhat, so I'm going to pick a somewhat arbitrary number for my limit. I'm going to say 50.
Sounds good.
Right? And again, now if I save this, back in the inspector, we will see now I've got a place for my crit bonus with a slider on it. And it's probably a little hard to tell on the live stream, but my default value is 1. You can clearly see that. And the slider is just a little tiny bit, approximately 1/50th of the way over in its range, because I've selected 1 as my value. And again, I can now slide that and manipulate it any way I want, or I could set it back to the base value by just typing it in, right? So now I am collecting all of the data I need to be able to support crits, but we got to make it work. So we're going to go back to our code and take a look. So one thing we can look at is how is damage being applied right now? And again, I could do a sort of long-winded navigation through the code, but I'm going to oversimplify in the interest of time a little bit, or just describe it at a high level. So what happens, and we've talked a little bit about this, I think, on prior casts, is during gameplay, when the laser bolt collides with an enemy, that causes, Natalie used this term before, an event to happen. And that event results in the enemy saying, oh, darn, a laser bolt hit me. And therefore, I must reduce my enemy health value by the amount that of damage that laser bolt inflicts on me. Right? In order to make all that calculation work, the laser bolt, the enemy has to know how much damage the laser bolt inflicts. And that's something that when that collision happens, what's going on is the enemy, the code for the enemy that I just described, it kind of asks the laser bolt and says, hey, how much damage are you supposed to do to me? And then the laser bolt says, I'm supposed to do 5 units of damage, or whatever I've selected as my base units of damage. And then the enemy very helpfully then says, okay, cool, then I'm going to reduce my health by 5 points, right? The place where that value comes from is here in my code. And what this is doing, this statement of code is doing, is it is basically saying whatever value is assigned to the m units of underscore units of damage variable, that's the value to report here. That's the value to report back to whatever is asking about it. In this case, that code in the enemy, right? And this is very straightforward. Now, what I've realized here is I can make a pretty simple modification to this line of code that's going to work all of the time with these crit rates and crit bonus rates to apply our crit formula, right? So here's what I want to do. And all I'm going to do now is in code, add the math we talked about before. So instead of just returning m underscore units of damage, I'm going to return, well, I'm going to start by saying return m underscore units of damage times m underscore crit bonus, right? And that's the part of our formula that says increase the damage, multiply the base damage value by whatever we said the bonus value here was, right? So if this value is 10, it will be m underscore units of damage by times 10 or 5 times 10 or 50, right? So that's how we're going to apply the bonus. Am I done with making this work the way we want to, Natalie?
I don't think so. You left out the crit rate variable that you created. And so I'm wondering how you're going to incorporate that.
Yes. And so right now, Natalie, with that missing, what would happen if we played our game right now? How would this code work without that part in it?
Well, without the crit rate, it sounds to me like you're going to get the crit bonus on every single bullet.
I think that's exactly right. That would happen. Now, again, with the way things are set now, that would have no effect on the gameplay. And that's why I chose the default values that I did. Because right now that's set to 1. It would always be 5 times 1, which is 5, which is the same as just saying the units of damage, right? But we've got to do one more thing to make this work, which, just as Natalie says, is to apply the crit rate so that this is only critting a certain percentage of the time, the percentage of time that we've set under crit rate. And that's where we're going to pick up next time.
I was about to be like, whoa, I don't know if we can get that equation down in a minute.
I don't think we can. But I think it's a good thing to leave folks thinking about, because remember, what we can do in a minute or two, of going over here, is think very clearly and describe the algorithm, the procedure for doing that in normal English, right? We know we want the crits to only happen some of the time, whatever we say is the crit rate. Let's say it's 25% of the time for the sake of this example, right? Which would mean we only want 1 out of every 4 shots to be a crit, right? 25% of the time, 1/4 of the time. Do we want every 4th shot to be a crit, though?
No, we don't want it to go that logically and rhythmically. Like, we don't want it to play like 1, 2, 3, crit, 1, 2, 3, crit, because then you could use that as a part of your strategy. And this is supposed to be somewhat random, right?
Yeah, we need a randomizing element in here. And if we were thinking about this logically, right, what we effectively want is every time that a projectile collides with an enemy, we want the projectile to have a 1 in 4 chance of being a crit. And we essentially, as you say, Natalie, want that chance to be random. So if we were going to visualize this, right? Imagine we had a four-sided. Well, let's make it a simpler example. Let's say we wanted it 1 out of every 6 shots to crit, right? We could visualize that by saying every time a shot collided with the enemy, we were going to roll the dice. And if the dice came up with a roll of, it could be any number, let's say 6, right? Then we were going to crit. And if it rolled any other number, it would just be the base damage. It wouldn't crit, right? The dice is the randomizing element there, because assuming it's a fair dice, it's only going to, there's an equal chance of it being any of the 6 values, and we want it to crit one of the 6 times, and so the rolling a 6 would be approximately 1/6 of the outcomes on a fair dice. That would let us do that at random. So what we need to add to our instructions here is a way of saying, hey, effectively introduce a random element into this process so that only 1 out of however many times is specified by crit rate are you actually going to crit, right? But we need a way for that to be random, rather than, like in Natalie's example, of a non-random either happening all the time or happening non-randomly in a pattern like 1, 2, 3 crit, 1, 2, 3 crit. And so we have to devise an algorithm using the tools at our disposal here in Unity Code to do that. And so that's going to be our task for next time, when we pick up for next time. And I think, Natalie, next time we can do that, we're going to apply the same techniques to do the multiplier fundamentally. We can test those things a little bit in the game to see that they're working the way that we expect. And then we can probably move on a little bit to the more meaty stuff and start our waves implementation. And certainly, Natalie, when we do that, I'd like to hand off some of the coding of that to you so we can both take some turns at driving, because I've been driving a lot these last couple of casts. Oh, I think you're muted, Natalie, all of a sudden.
I'm back and I'm not muted anymore. I was going to say that all sounds great, and I'm looking forward to getting in there and coding a little bit myself. So,
sounds good.
We'll be back with you guys tomorrow.
All right, we'll see you tomorrow. Thanks for watching.